Hey everybody, welcome to part one of the time value of money lesson. So you may be watching this as as part of a series, or you may be watching this just because you want to get to know whatever is, kind of the basics of TVM. Whatever the case may be, please don't be shy to leave questions in the comments, and I'll be sure to answer them as soon as I see them. Okay, so today we're looking at TVM. You may know TVM already, but I'm going to go on the assumption that everyone here is brand new to it. So let's start from the very beginning. What is TVM, right? What is the time value of money? Basically, what we're looking at here is the relationship between money, time, and some interest rate, right? Think about money, right? You have $100. Well, if you take $100 and you add time to it, nothing really happens, right? If you put $100 under your mattress for a year, go back a year later, it's still going to be $100. Why? Because you don't have interest. If you have money and interest, but you don't have time, nothing happens, right? If you put $100 into a bank account that pays you 5% interest per year, immediately nothing would change. You still have $100 because you need time to kind of pass for that money to grow. But when you have all three of them, then you have the magic. Take $100, put it into your bank account that pays you 5% interest. A year later, you're going to have $105, right? That is the time value of money, and we're exposed to it in our everyday lives. If you have a credit card, you've been exposed to TVM. If you have a bank loan, you've been exposed to TVM. If you have a savings account, if you've invested in stocks and so on. So TVM is really all around us. What we're going to be looking at in this lesson is the kind of the fundamentals, right? What are the basic operations? What are the things you want to look for? So let's start with the big 5 variables. And there's a lot that goes into TVM, but really revolves around these 5 things. The present value and the future value. These are what we call lump sums. Okay, you can take little notes along the way. By the way, don't forget to download this PDF so that you can follow along and take your own notes. So these are lump sums. These are basically just amounts at particular points in time. So the present value is a value today, some amount today at the present day. The future value is some amount in the future. So for example, if I have $1,000 today, that's a present value. But if I want to have $1,000 in 4 years, that would be a future value. The symbols are pretty self-explanatory, PV and FV. And then the calculator buttons, right? We're going to be using a financial calculator for a lot of stuff. And so we use it's the same buttons on the financial calculator. And then you've got your effective rate. This is basically the interest rate. Now, the effective rate, we'll get into this a little bit more later, is not necessarily the APR, if you've heard of that before. For now, just know that the effective rate is the interest rate that we use in whatever the context may be. The symbols, there are many different symbols. You might use K, you might use R, you might use I, right? Those are all the same. I tend to use K, and so I'll be using K for my effective rate throughout. That's when I'm using formulas. On the financial calculator, the symbol or the button is I over Y. Then you've got the recurring cash flow. In some instances, you don't have lump sums or only lump sums. You have recurring cash flows, right? Think of a mortgage where you have to make monthly payments. Well, that monthly payment is a payment. It's recurring. And so the symbols for that, A, C, PMT, right? There are many different symbols that you can use. I tend to use PMT, payment. It is the same button on the financial calculator. And finally, the number of periods or the number of payments. The symbol for that is kind of universally N. All right. And most of the things you're going to be solving for, or most of the questions you'll be dealing with, will kind of revolve around those 5. Find present value, find the payment, find the N. How long will it take for you to triple your money, right? That would be looking for N. How much should you save today if you want to have $5,000 in 10 years? If you have $5,000 today, how much will you have in 20 years, right? These are all the things that we can solve using the mechanics we're going to learn today. Okay, let's start with the most basic one. These are lump sum calculations. This means finding a present value and finding a future value. We're not going to get into payments just yet. We're just going to deal with lump sums. So taking one amount from a specific point in time and just moving it to another point in time. So, for example, I have $1,000 today. How much will I have in 4 years? That would be taking a present value and turning it into a future value. Or I want to save up $20,000 to go on a trip in a year from now. How much should I save today? That would be taking a future value and pulling it back. That's called discounting. Discounting is when you find the present value of something, right? Compounding is when you find the future value, when you want to push something ahead. And you've got your two main formulas. These are like the most basic formulas in TVM, the basic present value and the basic future value. So the basic present value, you can see, is the future value divided by 1 plus your effective rate to the power n. And if you want the future value, it's basically the same thing if you rearrange it. You take the present value and you multiply it by 1 plus k to the n. Now, as far as k and n and all that stuff, well, n is based on the number of years, which is t, and your compounding frequency. Now, we'll get into what compounding means more in detail later, but very quickly, compounding is just how many times a year your interest is, well, compounded or calculated. Take, for example, this timeline, right? This line represents 1 year, 0, 1, okay? But if you have a 10% interest rate that is compounded 2 times per year, well, it's not actually 10%. It's 5% 2 times a year. Now, that might sound like 10%, but it's not, because this 5% will compound on this 5% and so on. Now, what does compounding even mean? When I say this 5% is going to compound on this 5%, well, let me show you what compounding really means. Let's say we take, get rid of this, okay? Let's say you have $100 today. You put that in your account. Well, if your interest is being compounded semi-annually, 6 months later, you're going to gain $5, right? You're going to gain 5% of your previous balance, right, which was $100. So you're going to gain $5. So now you have 105. Great. 6 months later, the same thing happens, except now you're gaining 5% on 105, which is $10, or no, I think it's $5.25. You see? You're gaining more, so now you have $110.25. Your money will grow exponentially because you're earning interest, not just on the principal, but you're earning interest on interest. You see, here, this $5 was interest just on the principal. But here is $5.25. That extra 25 cents is what we call interest on interest. That's interest you earned on the previous interest. And the more you leave your money, right, the more you let it compound, the more interest on interest you'll earn. Now, there's something called simple interest. Simple interest is not something we see very much anymore, but it's important to understand the concept. Simple interest is when you're only earning interest on your principal. Now, we're going to get more into that in another lesson, but just something to keep in mind. Simple interest is interest earned only on the principal. So imagine here, in this case, I was earning $5 every period, right? If I were to draw another timeline where, you know, it's just like this one, but it was 5% simple interest, well, I would be gaining exactly $5 every single time, you see? Because I would be earning the interest only on the principal. There would be no interest on interest. Again, more on that in another lesson. For now, understand that your compounding frequency will play a role in, you know, the how fast your money grows, basically. When we're doing lump sums, and this will get more complicated later, but when we're doing lump sum calculations, your effective rate can be found simply by taking your annual percentage rate, which is the interest rate stated for a year, divided by your compounding frequency. Okay, so let's do an exercise so you guys can kind of get the idea. Continuous compounding, before we do the exercise, is the absolute fastest you can compound interest, or the most you can compound interest, right? So typically interest is compounded periodically, like every month or every quarter or every day even. But in theory, right, interest can be compounded continuously or an infinite amount of time. Just think of it as like more than every second. Well, in that case, the equation changes a little bit. We have to use the exponential variable. And the future value now becomes present value times e, your exponential variable, to the power APR times t. This is just a formula you're going to want to know. It's not very common in most TVM cases. There aren't very many real-life examples of this, but you may come across it on an exam. So let's start with our first exercise here. So you've got $1,000 today. That makes this a present value. And you will deposit this into an account earning 8% interest per year. Okay, great. So 8% interest per year, that's going to be our K. How much will you have in 5 years? So for this, I'm looking for the future value. So this is our formula right there. So we're going to do 1,000, that's your present value, multiplied by 1 plus K, that's your K, your interest rate, to the power 5. So that's $1,469.33. You'll have $1,469.33 5 years from now. You just borrowed $10,000. Again, you just borrowed it, making this a present value, and you will repay it in a single lump payment in 4 years. Okay, the lender will charge you 9% interest compounded monthly. Okay, so here we have, and what's important also when you're going to be reading questions is understanding when I give you an interest rate and I tell you also the compounding frequency, understand that this is an APR. It is not your K. Look at the difference between this one and the previous one. Here I just said 8% per year. I didn't say 8% per year compounded monthly or compounded daily. I just said 8% per year. That makes that an effective annual rate. That is the actual interest, the actual K that you should be using. But if I say 9% interest per year, compounded monthly, this is an APR with an M, a compounding frequency of 12. So we're still looking for the future value, but now we're going to do it this way. The present value is 10,000. Multiplied by 1 plus, and for K, we're going to use 9% divided by 12. Close your bracket. And for N, remember what N is. Years, so years are, we have 4, times your compounding frequency. And this is because your K and your N always have to have the same time frame. So if your K is a monthly rate, which is what it is here, we took our annual rate and we divided it by 12, so that's a monthly rate. Well, if K is monthly, your N also has to be in months. If those two don't match, you're not getting the answer you think you're getting. It's very important. Your K and your N, your rate and your time should always be in the same unit of time. And then you punch it in. So 10,000, 1 plus 0.09 over 12 to the power 4 times 12. So $14,314.05. Okay, great. So now I want to take a second to introduce to you guys the financial calculator for those of you that are going to be using this in your class. If you're not going to be using the financial calculator, you can kind of skip over this part. So the financial calculator that I'll be using is the Texas Instrument BA2 Plus. It is kind of the gold standard, in my opinion anyways, but you know, in all the situations that I've seen, most people are using this one. Most other financial calculators will work the same way. Now, it works pretty much the same as you would as your formulas. It just does the formulas for you, right? But as far as like what to enter as what, it's pretty much the same thing. So just to introduce to you guys, again, we have the 5 main variables in the middle, right? N, I, Y, PV, PMT, and FV. And the way that you enter values there is you first type in the value and then punch it in. So let's say for question number 1 here, we had a present value of 1,000. So I'm going to enter 1,000 as my present value. And generally, for the financial calculator, you want to enter present values as a negative. Now, the reason for that is the calculator needs to understand, well, is this an inflow or an outflow? And very often it doesn't actually matter, but for the calculator it does. So if you will deposit this money into an account, think of that as the money leaving you. So it's negative. So we're going to enter 1,000, make it negative by pressing the button at the very bottom, and then assign it to whatever you want. I want to assign it as present value, so you just press present value. That's it. Then we had our N. Our N was 5, so you press 5N. The order doesn't actually matter, so 5N. Your interest rate was 8, so 8 IY. And we're looking for the future value. We don't have a payment. Now, what I like to do is whenever I don't have one of the 5, just set it as 0. This will delete anything that might be stored in there from the previous time you used it. So for now, it might be brand new and it doesn't matter. But as you start to use the calculator a lot, then you start to have payments, you want to make sure that you're clearing out all the old data. So 0 PMT is kind of overwriting anything that might have been stored in there. Okay, now we want to, and I'm going to zoom in a little bit here. We want to look at something called PY and CY. If you press the second function button and then IY, that'll take you to PY. For now, we want these both to be set to 1. So if it's already set to 1 on yours, great, don't change it. Scroll down by pressing the arrow, that's also 1, perfect. We'll get more into this later on. For now, we're going to keep these both to 1. Why? Well, when you already have your effective rate, so when this is your K, these should always be set to 1. I'll show you using the next question what to do when that's not K. But if your K, if your effective rate is what you're entering as the IY, well, PY and CY should be set to 1. In fact, you technically never need to use PY and CY, ever. As long as you're remembering that your IY should always be set to your effective rate, it won't matter. Now, throughout this lesson and other lessons, I will use it because some of you might want to use it. Some of you might like it. It does make it a little bit faster in some cases, but there's no rule that says you have to use PY/CY as long as you're always finding your K. All right, for now, you can ignore that. So let's punch everything in, right? So we already entered our payment as 0, our N is 5, our IY is 8, and our present value is 0. Now, once you've entered it, you ask the calculator to compute. So top left button, future value. So compute future value, and you get 1,469.33. The exact same answer we had before. So the calculator just does the math for you. Let's try on this one. So here, it was kind of the same thing. Our 10,000 negative is the present value. But this time your N is 48. It's not 12 or 4. You have to enter it the same way. So 48 is your N. Now, you have a 9% APR. On your financial calculator, you could enter that as IY. Except this time, because that's not actually your K, you could enter your PY and your CY. So my advice, I guess, here would be not to use it. Now that I'm thinking about it, I don't want to overcomplicate it for you guys just yet. So here's what we'll do. We'll keep those as 1. And we're going to enter 9 over 12. And that actually reminds me, I didn't say it before, but I need to say it. It's very important. On the financial calculators, you don't enter percentages in decimal form. You enter them as percentages. I didn't say it before, but I just entered 8 here. Okay, I didn't put 0.08 the way you would say if you're using a formula. So on your financial calculators, you enter things in interest rates, anyways, as whole percentages. So instead of writing 9 over or 0.09 over 12, I'm going to put 9 over 12, and 9 over 12 is 0.75. That's your periodic rate. Again, there's no payment here, and we're going to compute the future value. Okay, so I'll do it on the screen here. 10,000 negative PV 48N 0.75 IY 0 payment, compute future value, and I get 14,314. Exactly what we found before. Okay, let's continue with question number 3. You need to save up 50,000 to go on a tour of the world. You plan to depart in 4 years, making this a future value. How much should you deposit today into your savings account earning 9% interest compounded weekly? So there's your APR of 9%, And your compounding frequency is 52 because there are 52 weeks in a year. So we're looking now for the present value. We're going to use this formula here. So the present value is the future value for 50,000 divided by 1 plus, and for K, we'll do what we did before. It's the APR divided by your compounding frequency. And then your N, it's 4 years times your compounding frequency. And then you punch this in. So 50,000 divided by 0.09 over 52 to the power 52. You should get 34,894.67. If you were doing this on the financial calculator, the 50,000 would be your future value. So you would enter 50,000 as your future value. You would enter your N as 4 times 52. So 4 times 52 is 208. That would be your number of periods. 9 over 52 is your IY. Now for this, you want to try not rounding too much. And if you could not round at all, that's even better. That's your IY. Again, we're not using PY and CY, so those will, you don't have to change them every time or check them every time. Just know that we're not messing with these just yet. And the present value is what we're looking for, so there's no payment, so 0 PMT. Okay, you enter those and then you compute the present value. Okay, so I'll pull up the calculator here. 50,000 future value. 208 is the N, and I'm going to do 9 divided by 52 directly on the calculator, and I'll use that entire number as my IY. 0 payment, compute present value. And I got 34,894. Again, the answer being negative on the calculator is not actually, it's not actually negative. It's just how, again, how the calculator gives you the information. But then it depends on your context. Like, you're not depositing negative money. That wouldn't make sense, right? You're depositing 34,894. Now, another thing I want to mention for those of you that are, let's say, using your calculators for the first time is your calculator might be rounding too much by default, right? If you open these, I think, out of the box, they round to 2 decimal places, right? So they do something like, if I reset my calculator, I'm doing a factory reset here, look, it's going to give me, if I do 9 over 52, 9 divided by 52, 0.17, and that is way too much rounding. So here's how you change that on this calculator. You need to press second function, okay, and then format, the very bottom of the calculator, right? It's the decimal button. You see format. This is where you go. So this is set to 2. I don't want this set to 2. I want this set to maybe 8. So you'll press 8 and then enter at the very top of your calculator. Now, when I say enter, I don't mean equals, right? Enter is a button at the top of the calculator. Now, everything I do, the calculator will round it to 8 decimal places. Okay, so let's move on to question number 4. You just deposited $4,000 into an account. So this is present value, earning 9% interest per year compounded continuously. Oh, great. In 3 years, you'll make another deposit. And in 7 years, your goal is to have saved up $12,000. How much should you deposit in 3 years? And when it starts to become a little bit complicated, you want to start drawing timelines. And this is something you'll see me do in pretty much every lesson, just to make sense of it. Like, I'm going to deposit $4,000 here, and then the goal is that at the end of 7 years, I'll have 12,000. So, and it says that at the end of the 3rd year, you're going to make an additional deposit. When you're drawing timelines, time 0 is today, and then each of the ticks on your timeline represent the end of that period. So the X there is placed at the end of year 3. It's always like that. So the question is, okay, if I want both of these to add up to 12,000, how much should X be? Well, first of all, let's go and grab our formula. We know the future value using continuous compounding is this formula right here. So if you want to have 12,000, the basic idea is that the future value of the 4,000 and the future value of the X should add up to 12, meaning, let's start with the 4,000. If I take 4,000 times E to the power, the APR, which is 9%, times 7, because this 4,000 will stay in the account for 7 years, this is going to give me the future value of the 4,000. That number plus, if I do the same thing, X times E to the 0.09. Now X is only going to be in the account for 4 years, right? From year 3 to year 7, it's going to be in the account for 4 years. So times 4. I want both of those future values to add up to 12,000. So again, before I calculate it, just make sure you understand and you're not getting kind of overwhelmed with all these numbers. This is simply the future value of the 4,000. This is simply the future value of X. Together, we want the future value to equal 12. And then you just solve this algebraically. We'll start by punching this into our calculator. 4,000 times E to the power of 0.09 times 7. Okay, so this is going to grow into $7,510.44. Plus, this whole thing, I can punch into my calculator. So E to the power 0.09 times 4 is about 1.4333. I'm going to keep 5 decimal places. That should be enough. X equals 12,000. And now we just keep working it down, right? So we'll bring this over. So 12,000 minus 75,1044. Now I've got 1.4333. 3x equals 4489.56. And I'll divide that by 1.4333. Which tells me that that amount should be $3,132.26. You might get a slightly different answer if you round it differently, but this is it. If you deposited $4,000 today and then $3,132.26 3 years from now, in 7 years, you would have exactly $12,000. Now, you can't do this with a financial calculator, right? So there are certain things, there are many things actually that you cannot do with a financial calculator. So then you would have to use your formulas. Okay. So that's it for this first lesson on TVM. In the next video, we're going to get into how to calculate the present and future values of more complex timelines called annuities and perpetuities. And to do that, we're also going to really drill deeper into effective rates and how to calculate those. So if you want to watch that, please go ahead and do that. And I appreciate you guys being here. If you'd like to follow along these videos, feel free to subscribe to the channel. And as I post them, you'll be notified. Okay, thank you, and see you at the next lesson.